Bismillahirrahmanirrahim. Greetings. This video lecture is going to be continuation of the previous one, in which we are trying to discuss about the irrationality of square root of 2. Now, in this video, first let me give a short summary of the contents of the previous video, and then we have a new version also about the proof that I will be going through. Okay, what happened is that we made the assumption, which is a statement, that a square root of 2 is a rational number. Then we say, okay, if it is a rational number based on our assumption, then should satisfy the definition of rational number, which means any number that can be represented as a p over q, where p and q are what? Are integers. And in our proof, we are dealing with natural numbers, positive integers. So we said the square root of 2 to be equal to p over q according to our assumption. Then we did some simple algebraic manipulation, and we end up with 2q squared equals to p squared. And then we argue deductively, in a sense, that since the left side of the equation is an even number, therefore p squared must be even. And if p squared is even number, even integer, then p must be an even natural number. So since the general form of any even integer is 2m, so we let p to be represented as a 2m. Again, please don't make it difficult, just put few numbers, and if you have difficulty to comprehend it, make numerical example of your own and follow the steps that I'm saying. Then that will be a stay with you forever. Okay, so we let the p to be 2m, and with respect to that we wrote 2q squared equals to 2m quantity squared, and after simplification we end up q squared equals to 2m squared, which means q squared now must be an even integer, an even natural number. And then after that, we end up that if q squared is even, q must be even. So we write it in the form of 2n, just to make m and n different. We wrote this n. So we write q to be in the form of 2n. Now a square root of 2, or initially we let it to be equal to p over q. So now our p is 2m, and our q is 2n. So numerator and denominator, they have the factor of 2 in common. So when we cancel those two, we end up with a square root of 2 equals to m over n. Here you are. The contradiction starts because we are going around the circle. We are in a square one. So this process can be repeated indefinitely forever. And we know that is not the case for the rational number. If you have a rational number a over b, and they are not relatively prime, they have factors in common, we can cancel the factors. If they have factors in common again, we cancel again. If they have factors in common again, we cancel again. So we can do it for 3, 4, 5, at most 10 times. So, but here, this is not the case. This is the case that we are going around the circle, and same thing comes up again and again, and we go forever. So that is immediately a clear indication of a contradiction. Now I have put them on writing, so repetition help for the beginner students. So I go through that one more time, and then we go to the next version of our proof, in which we assume P and Q to be relatively prime, which means the only factors that they will have in common will be 1. So let me zoom this one and stay out of your way, and we go it that way. May I please? Okay. So again, what I just said orally, I'm going through that again. And this is review of the previous lecture. Now here, square root of 2 we assume to be in the P over Q. Why? Because we are, according to our assumption, a square root of 2 is a rational number. Therefore, we should be able to present it in the form of P over Q, where P and Q are what? In this case, are natural numbers. Then we do some algebraic manipulation, squaring both sides, and then we will end up with this form. Now, the left-hand side is even, is that right? Therefore, P squared must be even. So if P squared is even, that means P must be even. So we write P in this form, P equals to 2m. That is the general form that we can represent any even number. So now, this one, we replace P with 2m. And we do that, and we raise to the power, we end up with 2q squared equals 4m squared. We simplify 2 and 2, 2 and 4, they cancel, so we end up with q squared equals to 2m squared. Now, q squared is an even, because the right-hand side is an even number. Therefore, q must be even. So we write the q in the form of 2n, which is general form of representing an even number. So now, look what happens. Let me go here. Let's look what happened. Our P equals to 2n. Our Q equals to 2n. That's the representation. So a square root of 2, now instead of P over Q, we can write it in this form, 2m over 2n. Do you follow that? No, they have 2 in factor, we can see that. So we cancel 2 and 2, we end up with a square root of 2 equals to m over n. That's exactly what we started with. You see that? That's exactly what we started with. P over Q, m over n, same. So we are going around circle. We are in a square one. So that's enough at this time to stop and say that is contradiction, because this can continue indefinitely, forever. So our inference will be what? Will be that our assumption was false. Therefore, the negation of that, which indicates the square root of 2, is not a rational number, should be true. Okay, then let me, so yeah, I did write that one for you. Now let's go to our next version of proof. They are all equivalent, the first one, second one, and this will be the third one. Okay, in this version, let me cover it. So this is our next version. In this version, we add a restriction to our assumption. We add another let's say in the language of logic, we add another kind of premises in our assumption. And the premises that we add is that a square root of 2 equals to P over Q, where P and Q are relatively prime. Means that P and Q, they have no factors in common except 1. Like 2 and 3. 2 over 3 are relatively prime, which means the only factor they have in common is 1. Or any other, like 5 and 6. Like 7 and 5, etc. Thousands of that you can make. So now we add that restriction. We said that the square root of 2, is P over Q, where P and Q are relatively prime. This is a notation, in fact, we use for the indicating that is relatively prime. There is a parenthesis I missed to write. Okay, now we go through the same thing again. A square both sides, is that right? So we end up that P should be even, so we write in the form of 2m. And then we write for the P here, we write for the P 2m, we end up with 4m squared, then simplify, so Q squared now should be even. If Q squared is even, then what? Then Q must be even. So right now we have Q is in the form of 2n, which is an even number. P is in the form of 2m, which is what? Which is an even number. Therefore, the representation of our square root of P over, square root of 2 P over Q now can be written as 2m over 2n. You see that? But our assumption was what? Our assumption was that P and Q were relatively prime. And do you remember that I said you do not question your assumption? Based on that assumption, you continue. And I also made in the previous lecture that you can make an assumption that moon is made out of green cheese. Nothing wrong. That is a statement. Then you go through and say, you come to the inference that your assumption was false, therefore negation of that must be true. So our assumption was that P and Q were relatively prime. They had no factors in common, but all of a sudden we see they do have factors in common, which is 2 and 2. And that is contradiction. So that is proof by contradiction. Okay, let me zoom this one on and say a few words before I end this one. Okay, then I will be uploading another short lecture going through all three of the proof that we gave, the three lectures about discussing that the square root of 2 is an irrational number, is not a rational. And then after that, the next video that comes, I'm intending to upload another lecture that will be for a student having a bit more maturity in mathematics. Because these lectures are for the beginners. That is the reason I go and repeat a few times, put it in writing, because the beginners need a little bit more time to comprehend the subject. So repetition helps a lot. Okay, then I thank you very much as always for watching. I hope these videos are beneficial to you. And please do not forget and feel free to make any comment, any suggestion that could be helping me to enhance my teaching further. Okay, then again and again, I wish you all prosperity and good health, and please stay and remain healthy. So long. Ay, ay, ay.